In this video, I will be covering the basic properties of exponents. So what is an exponent? Basically, an exponent is a shorthand way of writing something. So for example, if I had 3 times 3 times 3, you see I've written 3 times. I could also write this as 3 to the third. This is an exponent. So instead of writing 3 times 3 times 3 and writing out the whole thing, I can simplify it as 3 to the third power. So that's what an exponent is 3 multiplied by itself 3 times. So for the first property, it states that if I have a number, let's say I have a number a, is raised to a power, let's say I have m. So if I have a raised to the m, and if I multiply this by the same number a raised to another power n, then what I could do is I could simplify this to equal a m plus n. So I would add the two exponents. And this is the first property. So another explanation of this, so let's say I had 3 to the second times 3 to the fourth. So how I would simplify this, it would be 3 to the sixth. And the reason why it's 3 to the 6th using this property is if I were to write this out, which is 3 times 3, so 3 2 times, multiplied by 3 times 3 times 3 times 3, then this is how many 3's are there. 1, 2, 3, 4, 5, 6. There's 6 3's, and it's also the same as 3 to the 6th. So 3 is multiplied by itself 6 times. So that's the reasoning, the basic reasoning behind this property. The second property states that if I have a number, let's say n, or a, so I'm just going to use a throughout the rest of this video. So if I have a number a raised to the m power, and I divide this by the same number a raised to the n power, then I can simplify this to be a m minus n. So it's the opposite of addition, it's subtraction. So another basic explanation, let's say I use the same numbers, so 3 to the fourth over 3 to the second. I could simplify this as 3, 4 minus 2, and that equals 3 to the second. And the reasoning behind this is that if I have 3 to the fourth, which equals 3 times 3 times 3 times 3, and I divide that by 3 times 3, then these 3's cancel out, and I'm left with 2 3's, which equal 3 to the second. The third property states that if I have a number a raised to the power m, and if this whole thing is raised to another power n, then what I can do to simplify this is I can multiply the two exponents. So this would equal a m times n. So an example of this would be if I had 2 to the third power all to the second power. I could rewrite this as 2 3 times 2, which equals 2 to the 6th. The fourth property states that if I have a number a, and if it's raised to a negative exponent, so a negative m, you can simplify this to be 1 over the answer of the positive answer. So what I mean by this is that, so in this example, or in this, it would be 1 to the am. So in an example, if I show you, if I have 4 to the negative second, or the negative square, this would equal 1 to the 4 over square, and 4 square equals 1 to the 16th, or 1 to the 16th. So the answer of the positive exponent, which would be on the bottom of the 1. So that's the fourth property. The fifth property states that if I have a number a divided by another number b, so I have two different numbers, and I raise this to the m power, I will get the m, the exponent, will square both of these. So if this was square, so this would be a to the m over b to the m. So if I had, for example, 2 over x, let's just use a variable for b, 2 over x to the square, this would simplify out to square would distribute to both. So 2 squared equals 4 over x squared. So that's the fifth property. And the last property states that if I have any number a raised to the 0 power, it will always equal 1. And this is just a rule that, it's just a rule. Anything to the 0 power equals to 1. So if I had like 1 million to the 0 power, it equals 1. So now I'll be going over a couple of problems that incorporate all of these 6 properties. So example 1. If I have to simplify x to the 4th and y to the 3rd over x squared and y to the 5th. So how I could simplify this is by using one of the properties that if I use these two bases, I can see here these x's are the same base and these y's are the same base, and they have different exponents. So what I can do, since it's division, I can simplify this to x 4 minus 2 and y 3 minus 5. So what this equals to is x squared y, whatever 3 minus 5 is, just negative 2. And this isn't simplified yet because I have a negative exponent here, so I can simplify this more using one of my other properties, the negative exponent property. So basically what I'm going to do is I'm going to simplify this to x squared, make this y over y squared. And to simplify this even more, I can just put this over 1, multiply the two together, and I get x squared over y squared. And that's my final answer. Do another example. So for this example, if I have 4 over x squared, and I multiply this, or square it if I cube it, or square if I square it, raise it to the 2nd power, then what I can do is I square both the top and the bottom. So 4 squared equals 16, and x squared, what I can do is I x squared and I add both of them, and this would equal 16x to the 4th, and this would be my final answer. So thank you for watching, and I hope that I taught you a little more about what the basic properties of exponents are.